Good day everyone, I am Nicolas from BSc 3B Mathematics and I am here to discuss the Wilson's theorem. But before we proceed to our main topic, here are some information about the history of Wilson's theorem. Wilson's theorem is named after John Wilson, an English mathematician. This theorem was stated by Ibn al-Haytham around 1000 AD and in the 18th century by John Wilson. Edward Waring, a British mathematician, published this theory in 1770, but neither he nor his student John Wilson proved it. In 1771, a French mathematician, Joseph Louis Lagrange, presented the first proof. There is evidence that Leibniz was also aware of the result a century earlier, but he never published it. Now, let's talk about Wilson's theorem. Wilson's theorem says that, first, any number n is a prime number if and only if the quantity of n minus 1 factorial plus 1 is divisible by n. To those who's not familiar with factorial, let me define what it is. The factorial of a positive integer n is the product of all the positive integers that are less than or equal to n. As you can see, the notation for this is the exclamation mark. In order for you to understand it well, let's have an example. Suppose you have n is equal to 6. n factorial or 6 factorial is equal to 6 times 5 times 4 times 3 times 2 times 1, which is equal to 720, since 6 times 5 is equal to 30 times 4 is equal to 120 times 3 is equal to 360 times 2 is equal to 720 times 1 is equal to 720. Now that you know what factorial is, let's go back to Wilson's theorem. Again, as what I have said a while ago, Wilson's theorem says that any number n is a prime number if and only if the quantity of n minus 1 factorial plus 1 is divisible by n. For you to better understand it well, let's have an example. Suppose that n is equal to 5. Using the formula, the quantity of n minus 1 factorial plus 1, substitute the given value of n. So we'll have the quantity of 5 minus 1 factorial plus 1. The quantity of 5 minus 1 factorial is equal to 4 factorial. 4 factorial is equal to 4 times 3 times 2 times 1, which is equal to 24, since 4 times 3 is equal to 12 times 2 is equal to 24 times 1 is equal to 24. 24 plus 1 is equal to 25. And 25 is divisible by 5 since 25 divided by 5 is equal to 5. Meaning, the number n which is 5 is a prime number. In addition, Wilson's theorem also states that if p is a prime number, then the quantity of p minus 1 factorial divided by p or mod p is congruent to minus 1 the quantity of mod p, or the remainder is equal to p minus 1. Again, for you to understand it well, here are some of the examples. Suppose that p is equal to 7. Using the formula, the quantity of p minus 1 factorial mod p is congruent to minus 1 the quantity of mod p. Substitute the given value of p. We'll have the quantity of 7 minus 1 factorial mod 7 is congruent to minus 1 the quantity of mod of 7. The quantity of 7 minus 1 factorial is equal to 6 factorial mod 7 is equal to minus 1 the quantity of mod 7. 6 factorial is equal to 6 times 5 times 4 times 3 times 2 times 1, which is equal to 720, since 6 times 5 is equal to 30 times 4 is equal to 120 times 3 is equal to 360 times 2 is equal to 720 and times 1 is equal to 720. So we'll have 720 divided by mod p, or 720 divided by 7 is equal to 102 remainder 6. As we look at the formula, it says that the remainder is equal to minus 1 the quantity of mod of p, or p minus 1. And as you notice, the remainder of 720 divided by 7 is equal to 6, which is the same as 7 minus 1. Another example, suppose that p is equal to 11. Again, Using the formula, the quantity of p minus 1 factorial mod p is congruent to minus 1 the quantity of mod p. Substitute the given value of p. We'll have the quantity of 11 minus 1 factorial mod 11 is congruent to minus 1 the quantity of mod of 11. The quantity of 11 minus 1 factorial is equal to 10 factorial mod 11 is equal to minus 1 the quantity of mod 11. 10 factorial is equal to 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, which is equal to 3,628,800. So we'll have 3,628,800 mod p, or 3,628,800 divided by 11 is equal to 329,890 remainder 10. As we look at the formula, it says that the remainder is equal to minus 1 the quantity mod p, or p minus 1. And as you notice, the remainder of 3,628,800 divided by 11 is equal to 10, which is the same as 11 minus 1. Indeed, Wilson's theorem is a great way to easily know the remainder of the factorial of a prime number less than 1. That's all for today. Hope you learned something. Thank you for listening. Keep safe and God bless.